Hello, good morning.
Good morning, sir.
So we will continue chapter 1, and in chapter 1 we have done electric charge, methods of charging, and Coulomb's law also. If you remember, I hope you don't, but still if you remember, we have done till Coulomb's law. So next topic which we are going to discuss is electric fields. क्या कल मेरा लेक्चर नहीं था, वो तो सर नहीं आए आज, इसलिए है आज। किस्मत वालों को ही मिलता हूँ। चलिए ना, कोई दिक्कत ओके। बस ओके ओके। चैप्टर 1, chapter 1, electric charge and electric fields, and topic is electric field. Electric fields. Okay, could someone define what is electric field? Yes. Electric field. होता क्या है ये, वही तो पूछ रहा हूँ। Potential. Okay, electric field may be defined as the electric field is the 3D region. Electric field is the 3D region surrounding any charge, surrounding any charge in which another charge in which another charge in which another charge experiences force of attraction or repulsion. Force of attraction or repulsion due to first charge. Due to first charge. Okay. So this is first point about electric field. Electric field is a region surrounding a charge or surrounding a charge distribution. It may be a single charge or it may be a group of charges. Okay, so this is the region in which if you will take another charge, whether it is positive or negative, so the charge which is coming into the electric field or the charge which is coming into this region will experience a force. It may be of attractive behavior or it may be of repulsive behavior. So electric field is a 3D region surrounding any charge in which another charge experiences force of attraction or repulsion. And this force of attraction or repulsion is due to the first charge. First charge means the charge due to which we are defining the concept of electric field. Okay, so we can represent it in this way. Let's say there is a charge. Let me give it as capital Q, and surrounding capital Q in 3D region. This is a sphere which represents the 3D region. So this 3D region is represented as electric field of charge capital Q. Remember, it's 3D, right? It's 3D means in every possible direction or in each and every direction there will be certain amount of electric field, and due to that electric field another charge which is, let's say, here we have another charge which is, let's say, Q naught. This charge Q naught, when will enter into the region, then capital Q charge will apply some force on Q naught. It may be of attractive nature or it may be of repulsive nature. So this field is known as electric field, or this region is known as electric field. Interesting point is, if charge Q naught just outside the boundary of this region, red colored boundary, there will be no force on charge Q naught due to charge capital Q. But as soon as the charge Q naught will enter the region of capital Q charge, which is given by the red colored circumference, in that region charge Q naught will experience electrostatic force. This electrostatic force may be of attractive behavior or it may be of repulsive behavior. It will depend on the polarity of the charges. For example, if capital Q is positive and Q naught is also positive, so in this case electrostatic force will be of repulsive nature. And if capital Q charge is negative and Q naught charge is positive, electrostatic force will be of attractive behavior. Okay, understood or any doubt? I am first day today. Wow, ऐसा बोलना फिर. कभी चैप्टर खत्म हो गया, न्यू चैप्टर से स्टार्ट करूंगा फिर. अभी चालू हो गया वो. अभी चालू है क्या? फिर सर नीचे लो. लर्निंग इंग्लिश सर. Good, good, very good. You should learn. Yes, good, good. Me too, brother. मैम के सामने मत बोल दिया कि भाई बहुत बेइज्जती करेंगी. No sir, YouTube learner. YouTube learner. Oh, that's why I am first day today. But it's okay. गलती करता है इंसान तभी सीखता है. बट इसका ये मतलब नहीं होता कि पूरे दिन गलती करते रहे. नोट कर लो जल्दी से, फिर आगे कंटिन्यू करते हैं हम. ओ बेटे, पढ़ाई कर लो. स्टोरी बुक देख कैसी बता रहा है. डेफिनेशन तो बताई ना कहीं तेरे को, शायद 10 बार रिपीट हुआ हो, उससे क्या फर्क पड़ता। नालायक को सुधर जाओ सुधर, बदतमीज लोग। नोट कर लिया भाई, जहां बना लो जल्दी। So first point is electric field is the 3D region surrounding any charge in which another charge will experience force of attraction or repulsion. And the condition is if q naught is greater than 0, force will be of repulsive nature. And if q into q naught is less than 0, the force will be of attractive nature. Repulsive nature means the charges are of same polarity, either positive positive or negative negative. So if you will have both the charges with positive polarity, multiplication will be positive, and if you have both the charges with negative polarity, again multiplication will be positive. So if the multiplication of charges is positive, yes, तो ये क्या हो जाएगा आपका, रिपल्सिव हो जाएगा. एंड इफ द मल्टीप्लीकेशन इज लेस देन 0, इट विल बी ऑफ अट्रैक्टिव नेचर. Now about second point about electric field. Second point is that electric field E, which is, yeah, I should write it as electric field is a vector quantity. Electric field is a vector quantity given by E vector. And the next point is electric field E vector exert some force on charge q naught. Okay, in the discussion of electric field, we have two charges. First one is capital Q and the second one is Q naught. So in this case, capital Q is the charge for which we are trying to define, or for which we are going to define electric field. So this charge is known as source charge. Capital Q is source charge. And then we have another charge Q naught. Q naught is a charge which we are using to experience the electric field due to charge capital Q. So Q naught is known as, in this topic, Q naught is known as test charge. And there are certain characteristic properties of a test charge. ओके बताएं भाई, टेस्ट चार्ज क्या होता? कुछ बच्चे बोल रहे 4-5 बार हमने पढ़ा है सर. यस यस, क्यू नोट तो रिप्रेजेंटेशन हुआ, होता क्या है? यस, एनीवन? नो आइडिया. वेरी गुड. वही तो एग्जैक्टली पता होना चाहिए ना. क्वेश्चन तो यहाँ से भी फ्रेम हो जाएगा, क्वेश्चन बनाने वाला तो कहीं से भी बना देगा, सर्सन रीजन में बना देगा क्वेश्चन. टेस्ट चार्ज का डेफिनेशन लिख के दे देगा, पूछ लेगा बताओ कि सही है कि गलत है. बताओ फिर कैसे पता करोगे? फिर बोल देना सब राम भरोसे अल्लाह भरोसे, और क्या. पॉजिटिव चार्ज का सर बहुत छोटा मैग्नीट्यूड से डेफिनेशन फ्रेम करना है. अच्छा, गूगल गया शायद, एआई. चलो सही है वैसे. टेस्ट चार्ज इज रिप्रेजेंटेड इन दिस केस क्यू नॉट. एंड द फर्स्ट पॉइंट इज दिस टेस्ट चार्ज is of positive polarity. And the second important point is this is a positive polarity charge whose magnitude is very small. So Q naught is tending to 0. Q naught is not 0, but Q naught is tending to 0, which implies that its magnitude is very, very small. Due to its small magnitude, electric field due to this test charge will also be tending to 0. Will also be tending to 0, which means we can define test charge as a positive charge whose electric field is negligible. Okay, so you can define test charge Test charge is a positive charge whose electric field whose electric field is negligible. In mathematical terms, Q naught is tending to 0 and electric field due to Q naught charge, let me give it by E naught. E naught is also tending to 0. So this is the test charge. So in our discussion, test charge is always going to be a positive charge or charge of positive polarity, always. Okay. Yes, or any doubt? Okay, next point is, if electric field E is a vector quantity, then what will be its direction? So we are interested in the direction of electric field E. Okay, could anyone tell me what is the direction of electric field E? Direction of electric field E will be same as direction of electric force F on charge Q naught. For example, ये मैग्नेटिक फील्ड में डिपेंड करता है, उसमें एंगल का भी थोड़ा झोल होता है वहां. तो डायरेक्शन ऑफ इलेक्ट्रिक फील्ड विल बी सेम एज डायरेक्शन ऑफ फोर्स ऑन टेस्ट चार्ज Q naught. Okay, remember Q naught is test charge in this discussion. So let's say I have a charge with positive polarity, capital Q, and there is another charge at some distance, test charge Q naught. We already mentioned that test charge is always going to be positive throughout the discussion. So if it is positive charge, what will be the nature of electric force between these two charges? They are the charges of same polarity. So will it be attractive or will it be repulsive? Repulsive. Since capital Q and Q naught is greater than 0, is positive, this implies that electric force is going to be repulsive in nature. So it will be a repulsive force. Now the second point, what will be the direction of force on charge Q naught? Towards charge capital Q or away from charge capital Q? If it's repulsive, the direction of force will be away from positive charge, like this. So this is the direction of F. And in the above statement, we have written that direction of electric field is same as direction of F, which means electric field will also be in the same direction. So E is also away from the positive charge. Okay. So from this discussion or from this definition, we can say that if we have a charge of positive polarity, electric field will be outwards from the given positive charge. So this is the representation for electric field E for a positive charge or charge with positive polarity. Magnitude of electric field obviously will depend on the magnitude of this positive charge. Let's take another case. If we have negative charge minus Q this time, and again here we have a test charge Q naught. What is the polarity of test charge? It's always positive throughout the discussion. It's not going to be negative. So Q naught is always positive. You have to consider it positive. Now, if you will look at the situation, multiplication of these two charges, because one of them is negative, one of them is positive. If you will multiply them, answer will be less than 0. So Q naught less than 0 indicates that electric force will be of attractive behavior or repulsive? Attractive. So this will be of attractive behavior, attractive nature of force. Now what will be the direction of force? Towards Q, capital Q I mean, or away from capital Q? If it's attractive, towards, because it will try to attract the charge Q naught. Yes. So this will be the direction of force in this case. And due to the direction of force, we can also comment on direction of electric field E, which will also be in the same direction. So if you will look at the electric field E in this situation, it is going towards charge capital Q, which is with negative polarity. So this suggests that if we have a charge with negative polarity, electric field is going to be towards the negative charge. So we can represent it like this. This will be the direction of electric field. Arrow indicates the direction of electric field. Arrow are coming, Arrows are coming towards the charge with negative polarity. So this will be taken as the direction of electric field. Understood or any doubt? In simple words, positive charge will emerge the electric field lines which are given by arrows in this case, or electric field is outward from the positive charge and electric field is towards the negative charge. If you will look at the situation where the electric field is originated and where it will end, the electric field is originated from capital Q charge with positive polarity, and it will go at a distance where its magnitude will be zero, and that distance in general discussion is given as infinity. So infinity will be the position, or infinity will be the distance where electric field due to plus capital Q charge will be zero. So at infinity point, magnitude of electric field is taken as zero. Okay? Yes or no? Same is true for negative charge. Electric field lines are coming from a point which is very far from the negative charge, that is infinity, and they are coming towards the negative charge. Again, at E infinity, value will be zero, which means infinity is a point, or infinity is a position in 3D space where the effect of electric field due to any charge, whether it is with positive polarity or negative polarity, is going to be zero, or at least we can say it will be tending to zero. Understood? Understood? So infinity, if you will look at infinity in a physical sense, in a practical way, it will be like there is a charge plus Q which is placed on the table, and due to this charge plus Q, there will be certain electric field in the room, right? So there will be certain value of E at the position of door, and value will go outside the room. Then the value of E continuously will be decreasing, and obviously there will be a point or position where E will be totally zero, and that position is known as infinity. So infinity in physics is not same as infinity in mathematics. Okay, infinity in physics represents a practical, what should I say, a practical point or a practical position with respect to the charge plus Q or minus Q. Are you getting my point? Are you getting it? Yes or no? Okay. Okay, so now we can define electric field E at a point P due to a charge capital Q with positive polarity or negative polarity, doesn't matter, magnitude will be same. So how to define it? So we are going to define a new concept here, which is given as electric field due to a point charge. Electric field due to a point charge at a distance r. At a distance r from the point point charge. Okay, so in this case we will define a new term which is known as electric field intensity. So let's define electric field intensity. Electric field intensity. Electric field intensity, which is given by E vector is equals to F vector divided by test charge. Remember, in this formula, if you are going to apply this formula, electric field E is electric force F divided by test charge. Test charge is the charge at which we are experiencing the electric force due to source charge. Source charge is capital Q in the discussion, and test charge is Q naught. So the definition of electric field intensity is given by F vector divided by Q naught. Okay. So if you will look at the magnitude only, magnitude of electric field E is equals to E, which will be magnitude of force, because force is a vector quantity. So this will be F divided by Q naught. And from here, we define the definition, or we define the concept of electric field intensity. So electric field intensity E is the ratio of electric force F and the test charge. Okay. So if you want to define electric field intensity, how will you define it? So there are two different ways to define it. First one is electric field intensity. Electric field intensity can be defined as the ratio of electric force F and test charge Q naught. Test charge Q naught. Okay, this is the one definition. Another definition, if you want to define, put Q naught equals to 1 unit. If Q naught is a unit positive charge, so unit positive charge means the value of Q naught is, let's say, 1 unit. So Q naught will be 1 coulomb in magnitude. Okay. If you will put Q naught 1 coulomb into the formula, you will get E is equals to F divided by Q naught. So F divided by 1 unit will be F, which implies that electric field E in terms of intensity is nothing but electric force F experienced by 1 coulomb charge. So another definition is given as electric field intensity. Electric field intensity is defined as the magnitude of force. Is defined as the magnitude of force experienced by 1 coulomb charge. 1 coulomb charge, or to be precise, plus 1 coulomb charge, because Q naught is test charge and its polarity will be positive. So this is another definition for electric field intensity. Either you can look at it in terms of force, or you can look at it in terms of ratio, which is F and Q naught. So E is equals to F by Q naught, and E is equals to F if Q naught is 1 coulomb. So electric field intensity is defined as the magnitude of electric force experienced by plus 1 coulomb charge due to the source charge, obviously. And remember, this force is electrostatic force. So I am not writing it again and again, electrostatic force. Force means here electrostatic force. Understood, or any doubt? If you will again look at mathematical arrangement of electric field E given by F divided by Q naught, you will get the SI unit for electric field E, and you will also get dimensional formula of electric field E. So from this representation, or from this formula, what will be the SI unit of electric field? Yes. SI unit of electric field. Electric field is given by force by charge. So what is the SI unit of force? Newton. And charge is taken in Coulomb. So SI unit of electric field is Newton per Coulomb, which can also be given as Newton Coulomb inverse. Okay. Now we are going to find out dimensional formula. Dimensions of electric field. So electric field E will have the dimensions of force F and charge Q naught. So electric field E will be equals to, in dimensions, what is the dimension for force? F. Dimensional formula of force. ML T minus 2. MLT minus 2 is the dimensional formula of electrostatic force or any other force. MLT minus 2 divided by charge. What is the dimensional formula of charge? AT. Yes, AT is correct. AT is the dimensional formula of charge. And if you will manage it, you will get the dimensional formula M, L, T minus 3 and A minus 1. Okay. One more unit you can obtain from the dimensional formula. If you will look at the fundamental units in E, we have M, which will be in kg. Then we have L, meter. Then we have time, second raised to minus 3. And then finally we have ampere, A inverse. So this is also a unit of electric field. E, kg, meter per second cube ampere. You can write it as kg meter per second cube ampere. Are you getting it or any doubt? Okay, could we move to the next point? So this was the concept of electric field intensity. But main topic was how to find out electric field due to a point charge at a distance r from this point charge. So let's find out the expression for it. Now we have a physical situation. Let's say there is a charge plus q at a point in 3D space. This is the point. And from this point at distance r, there is another point. Let me call this point P. And I want to find out the value of electric field. I want to find out the value of electric field due to charge plus Q, capital Q, at point P. What will be the value of electric field E, or what will be the electric field intensity E at point P due to charge plus Q at distance R? So we will use the basic definition of electric field intensity, which is given as, if you want to have E, that will be F divided by Q naught. So I will introduce Q naught at point P because I am interested in electric field intensity at point P. So let's say I put a positive test charge Q naught at point P. If the distance between charge plus Q, capital Q, and Q naught is R, what will be the electrostatic force or coulombic force between these two charges? So force F between plus Q and Q naught will be given by K Q1 Q2 by R square. Yes, familiar with the formula? Yes or no? Q1 Q2 by R square. This formula is known as what? Coulomb's law. Okay, now what is the value of Q1? Q1 is my source charge, capital Q. What is the value of Q2? Q2 is my test charge, Q naught, divided by R square. Okay, this is the value of F, force between them. Now we can define electric field intensity E by the formula F divided by test charge. Remember, I already told you, if you are going to apply this formula, if you are going to apply E equals to F divided by charge, remember charge is the test charge, right? In any discussion of electric field, in any numerical of electric field, there will always be two charges. First one, source charge. Second one, test charge. And remember, if you are going to apply the formula E equals to F divided by Q, in that formula, Q is test charge, not source charge. So this will be F divided by test charge, which is Q naught in this discussion. Now, if you will put the value of F is K, Q1, Q naught by R square, and overall division में आ जाएगा आपका क्या? Q naught, yes. So Q naught factor will cancel out, and you will get the formula of electric field intensity, which is equals to K, Q by R square. If I will write it in proper representation as is given in books, K is 1 upon 4 pi epsilon naught into Q divided by R square. So if you will look at the situations, 1 is constant, 4 is constant, pi is constant, epsilon naught is also constant, and Q is also constant, because for which charge we are going to find out electric field, that will be given to us. Given to us means the magnitude of charge is not going to change again and again. It will be a constant value. So everything is constant in the formula except R. R is the distance from the source charge. And remember, Q is what? Source charge. Q is source charge. So we can write it as electric field intensity E is a function of R. Is a function of R, which means it is connected with R. As the value of R will change, E will also change. Okay. So E as a function of R is given by 1 upon 4 pi epsilon naught Q divided by R square. So this is the formula, or this is the electric field at distance R due to charge capital Q, and this distance R is at point P. So if you will look at the factors which are connected with electric field, you will get first point, electric field at any distance R is directly proportional to the magnitude of source charge, and directly proportionality indicates that greater the magnitude of source charge, greater will be the electric field. Which means if I have two different charges, 1 coulomb and 5 coulomb, and due to these two different charges, I want to find out the value of E at the same point P. So 1 coulomb will give electric field which will be less in magnitude as compared to electric field due to 5 coulomb charge. Because magnitude of 5 coulomb charge is greater, so obviously electric field due to 5 coulomb charge will be greater than the electric field due to 1 coulomb charge. Remember, at the same distance we are talking here. R is not changing. R is constant in this case. Okay. So E is directly related with Q, source charge. Greater magnitude, greater electric field. Smaller magnitude, smaller electric field. Next factor from the formula you can have obviously R. So E as a function of R is inversely related with R square. And when you are going to check the value of electric field due to a given charge Q, Q will be constant in this case. And E is inversely related with R, which implies that if you will increase the distance, electric field will decrease, and if you will decrease the distance, electric field will increase. This implies that if you are going far from the source charge, magnitude of electric field will decrease, and if you are coming near to the source charge, magnitude of electric field will increase. Another interesting point into this proportionality is its power square. It's not simple 1 by R. If it's simple 1 by R, it means if you are increasing R by factor 2, E will reduce by factor 1 by 2. If you are doing R or increasing R by factor 4, E will decrease by factor 1 by 4. But here we are having square. So what will be the effect of square? Let's say if you increase R by factor 2, what will be the effect on E? It will be 2 square, which means 4. So when you are increasing R by factor 2, E will reduce by factor 1 by 4. It means as soon as you will go far from the source charge Q, the value of electric field will decrease very rapidly. In other words, अगर आप चार्ज के नियर बाय रीजन में हैं और आप चार्ज से दूर जा रहे, तो जितना ज्यादा आप दूर जाएंगे इलेक्ट्रिक फील्ड उतना फास्ट ड्रॉप होगा, विच मींस चार्ज क्यू से हर एक पॉइंट पर, लेट्स से ऐसा आप इमेजिन कर सकते हो इसे, दिस इज चार्ज क्यू एंड लेट्स से आई एम गोइंग इन दिस डायरेक्शन एंड देयर आर डिफरेंट पॉइंट्स. लेट्स से दिस इज पॉइंट पी, दिस इज पॉइंट क्यू, this is point R, this is point PQRS and so on. So what will happen is that electric field at point P will be greater than electric field at point Q, obviously will be greater, and it will be greater than ER. But if you will look at the magnitudes, you will notice that EP, electric field at point P, will be way bigger than electric field at point Q. And if you are taking it at same distance, like this is 1 unit, this is 1 unit, this is 1 unit, the separation between all the points is same, but still the magnitude of electric field will decrease very rapidly. Are you getting the meaning of R square? It's not simply R, it's R square. Yes, R squared means कि जैसे जैसे आप चार्ज से, सोर्स चार्ज से दूर जाएंगे, इलेक्ट्रिक फील्ड ई ऑब्वियसली डिक्रीज होगा, बट स्क्वायर यहाँ इंडिकेट कर रहा है कि वो बहुत फास्ट रेट से डिक्रीज होने वाला है. यस, फास्ट डिक्रीज होगा, स्क्वायर का सेंस यहाँ इतना ही है. अंडरस्टूड और एनी डाउट? यस, इतना खतरनाक कॉन्सेप्ट पढ़ा है मैंने, देखो वॉशरूम आ गया बच्चों को. बेटे अगर वापस ना आए ना 5 मिनट में, वो तो भरोसे है ना, डिपेंड करता है ना टेंडेंसी. नहीं नहीं, ये तो बात सही है तुम्हारी, टेंडेंसी बता रहा किस पे लायक है, ना लायक. E as a function of R is inversely related with 1 by R square. Okay, are you getting it? Okay, now next factor in the formula, we are left with only epsilon naught. And if it's not epsilon naught means that the charge is in vacuum. Charge is in vacuum. But if the charge is not in vacuum, then in place of epsilon naught, there will be epsilon. So we will look what is the effect of electric field on epsilon, or what is the effect of epsilon on electric field. So electric field at any distance R is again inversely related with epsilon. And epsilon, you should be aware about epsilon. What is epsilon here? In Coulomb's law, epsilon is nature of the medium. Nature of the medium. So electric field E is connected with nature of the medium. Nature of medium, which means the value of electric field E will depend on this point also, that in which medium source charge Q is placed. If the source charge Q is in vacuum and you want to have the value of electric field E at distance R, it will be different. And if the same charge Q is placed in different medium, let's say water, and you want to have the value of E at the same distance as in vacuum, in that case value of E in water will be different, it will be changed. Now the question is, how it will change? Will it increase or will it decrease? Yes, if I take a source charge from vacuum to a given medium, let's say water, what will be the effect on electric field due to medium, due to water? Will it be same? Will it increase? Will it decrease? Decrease. It will decrease. Remember, the value of electric field E at distance R is going to be maximum only in vacuum. Only in vacuum. If you will check the electric field E in any given medium other than vacuum, it will be always less than electric field in vacuum due to the same arrangement. Same arrangement means magnitude of source charge is exactly same. Distance r is also exactly same. Nothing is changed. Just medium is changed. In that case, electric field in any medium is always less than electric field in vacuum. And there is a relation between electric field in medium and electric field in vacuum. And that can be understood from the standard formula. I already given it to you in Coulomb's law. If you want to have F medium, if you want to have F medium as compared to F vacuum, this will be F vacuum divided by dielectric constant K. And E is derived from F, right? E is nothing but F by Q. Yes, E is F by Q. And in a special case, if I take test charge Q as 1 coulomb, E will be nothing but F. Yes, दूसरी definition जो मैंने लिखा है, E is nothing but F in a special case. So let's say Q is 1 coulomb. So where I am having F, in that place I can have E. So the formula will be E medium will be E vacuum divided by K, which implies that electric field in any medium will be 1 upon K times electric field in the vacuum. In other words, it also implies that the value of electric field in any given medium is going to be less than electric field in a vacuum. Understood or any doubt? In your book, it will be written as this: E is equals to E naught divided by K. E naught is for vacuum, K is dielectric constant, and E is medium. The value of dielectric constant is different for different medium. For example, value of K for air is 1, which is almost same as for vacuum. So in vacuum or in air, E will be approximate same as E in vacuum. But if you are having medium as water, K is, yes, anyone for water, 86.5 or approximate 86. So E in water will be E in vacuum divided by 86. For air, K is approximate 1. For vacuum, K is exactly 1. For water, K is approximate 86. And for metal, metallic conductor, K is infinite. Understood or any doubt? आगे चल सकते हैं हम लिख लो. Learning? Yes, sir. Good. Why are you laughing? Sir, why are you laughing? Why? Tell her. Tell her? Oh God. पता है ही मोटा है पर Done? Okay. Last point in electric field, that is, if we have an electric field in this direction, let's say this is electric field E, and we place a positive charge in this electric field E, what will be the direction of force on the positive charge? देखो ये तुम्हारा प्रेजेंस ऑफ माइंड है यहाँ क्लास में, ये मैंने अभी बताया तुम्हें और तुम फिर भूल गए। बस अब तो हो गया काम खत्म। ये देखो कहाँ लिखा मैंने, ये लिखा, direction of electric field will be same as direction of force on test charge, and test charge is positive or negative? Positive. It means direction of force on positive charge will be same as the direction of electric field. So the question is reframed. If we have electric field E as given in the figure, and there is a positive charge in this electric field E, what will be the direction of force on positive charge? Same to same means force will be in the same direction as electric field. And if you want to have its magnitude, what will be its magnitude? Let's say this charge is plus Q. So from the formula, E is equals to F by Q, you can have the value of F, which will be Q into E. So F will be Q into E. E is the electric field at this location or position in the electric field. Q is which type of charge in this formula? Test charge. Very good. And then we have negative charge. What will be the direction of negative charge? It will be opposite to the electric field, which means this will be in this direction, F. Again, formula is given by Q, E. And again, Q in this case is test charge. Understood or any doubt? Let's do some numericals. Question number 1, which states that an electric field of 10 raised to power 5 Newton per Coulomb points due west at a certain spot. At a certain spot. What are the magnitude? What are the magnitude and direction of force that acts on charge plus 2 Coulomb and minus 5 Coulomb at this spot? Are you getting the question? Question is, we have an electric field in west direction. So let me take it in this direction. This is the electric field, and this direction is taken as west direction. Okay, and the value of electric field in this space at certain point is 10 raised to power 5 Newton per Coulomb. Now the question is, if you put plus 2 Coulomb charge at this point, what will be the magnitude of force working on this charge, and what will be its direction?
Direction तो along electric field ही जाएगा west.
Okay, 4 plus 2 Coulomb we are talking. 4 plus 2 Coulomb. Direction will be same as electric field, means it will be due west. What will be the magnitude of force F? I am interested in F. So magnitude of force F. Formula for F is Q into E. Yes. Direction is already given, so we need not to write it in vector form. F is equals to Q into E. Now, in this case, Q is what? Test charge. And test charge is the charge for which we are calculating force due to electric field. So, in this case, 2 coulomb is the test charge. So, it will be 2. Multiply E is the value of electric field which is given to us 10 raised to power 5. So, F will be 2 into 10 raised to power 5. What will be the SI unit of F? SI unit of F, force. It will be Newton and direction will be west. Okay, next we have minus 5 coulomb. What will be the direction? Yes, direction for negative charge will be opposite to the electric field. If electric field is in west direction, force on negative charge is going to be in east direction, no doubt about it. So it will be east definitely. Now we are interested in magnitude of F, force working on minus 5 coulomb charge given by Q into E. Q is the test charge, and in this case the value of Q will be 5 into electric field E is 10 raised to power 5. SI unit will be Newton. Understood or any doubt? Next question. Next question is find the value of electric field intensity E at 2 meter distance from a charge of plus 10 coulomb. Also find the direction. Also find the direction of electric field E. ये बताओ भाई कैसे करेंगे? We have to find out the value of electric field, means magnitude of electric field at 2 meter distance from a charge of magnitude plus 10 coulomb. So the question is, we have a charge plus Q, and from this charge plus Q at any distance R there is a point, and we are interested in electric field E at this point P. So what is the formula for source charge? Yes, if you are calculating electric field due to source charge, in that case formula is K Q by R square. So according to question, which is source charge? 10 coulomb, and what is the value of R? 2 meter, and everything is in SI system, so we need not to change it. So electric field E at 2 meter distance, electric field E at 2 meter distance will be K. The value of K is 9 into 10 raised to power 9 into Q. Q is 10 coulomb divided by R. Distance R is 2 meter. So this will be 2 square, which means 2 into 2. You can write it as 9 into 10 raised to power 8 into 100 divided by 4. This will be 25. So what will be 25 times 9? Yes, 25 times 9 बताओ, ये तो पता होना चाहिए यार, ऐसा कर रहे हो आप लोग. 145. 25 times 9. 225. 225 into 10 raised to power 8. Convert it into scientific notation. बोलो आंसर क्या आएगा? पूरे बैच में कोई भी बता दो. 2.25 into 10 raised to power. पक्का? Yes. What is the SI unit for electric field? हे भगवान. SI unit for electric field Newton per coulomb. समझ में आ गई बात? लगातार मोबाइल चलाओगे अगर आप लोग पीछे बैठ के, भाई क्या फायदा होगा तुम्हें क्लास में आएगा? हर बार ये बात बोलनी पड़ती। कॉन्सेप्ट आते हैं तुम्हें?
सर मैं आता ही नहीं हूँ सर, क्लास में बीच में लेट होते हैं। आज भी स्टार्ट पूरा
तो गेम खेलोगे बैठ के?
सर गेम नहीं खेलना सर।
फिर क्या कर रहे?
वेब सीरीज पढ़ रहा था।
क्या पढ़ रहे बताओ?
हजार किलोमीटर
आवाज नहीं भाई। दिस इज अ गुड क्वेश्चन। देयर आर टू पॉजिटिव। मेरी बात जरा ध्यान से सुनो, क्लास में बैठना तो तमीज से बैठो, नहीं तो बाहर मरो। अगर इस बार मुझे गाली सुनाई दूं ना, तोड़ दूंगा हड्डे तुम्हारे। आ रही है बात समझ में? घर दियो अपने गाली जाके जिसे देनी। Question is two positive charges Q1 and Q2. Two positive charges Q1 and Q2 are separated in vacuum. Are separated in vacuum by a distance of 3 meter. Find the point. Find the point on the line. Find the point on the line between the charges. Find the point on the line between the charges where net electric field is zero. Net electric field is zero. ये एक अच्छे लेवल का क्वेश्चन है। ऐसे क्वेश्चन आते हैं भाई, आते हैं मतलब बोर्ड में भी आते हैं और नीट वगैरह में भी आते हैं। सो वी आर गिवन विथ टू चार्जेस, चार्ज Q1 and Q2, and magnitudes are 16 microcoulomb and 4 microcoulomb. They are separated at a distance of 3 meter, and we want to find out the point on the line joining these two charges where electric field will be zero. So let's say this is the line joining the two given charges Q1 and Q2. Separation between them is 3 meter. So first point, what do you think, where will be the point at which electric field E will be zero due to these two charges Q1 and Q2? Left, right, or in between? Left, right, or in between? In between somewhere. Is it possible that we can have a point where electric field is zero in left direction, in the left region? Is it possible? Yes. कैसे होगा बताओ? Charge Q1 and Q2 are having same polarity. So if you will take any point in left region, at that point the value of electric field E or the electric field E vector will be in the same direction due to charge Q1 as well as charge Q2. How will we check the direction? Let's say I randomly select a point here And I want to know what will be the direction of electric field vector due to q1 and q2. I will put here q naught charge, which is positive. And now I will look the direction of force. I already told you direction of electric field is same as the direction of force on q naught. Yes. So if it is positive charge, q naught also positive, E will be outward, repulsive. Q2 is positive, Q naught is also positive, again repulsive. So both the E vector, E1 vector as well as E2 vector are in the same direction, due to which they will never cancel out each other. So E is not going to zero in left region. Yes. But if you are going very far from this arrangement, then obviously E will be zero at some point. But that point will be infinity. Similarly for the right region. So there is only one choice we are left with to find out the point where E will be zero. It means it will be in between somewhere. Now, if you will look at the magnitude, it is 4 microcoulomb. It is 16 microcoulomb. Magnitude of the charges are not equal, which means the point of interest is not exactly between these two charges. अगर ये same होता 2 microcoulomb and 2 microcoulomb, answer will be exactly between. But right now, magnitude is different. One charge is 4 microcoulomb, another one is 16 microcoulomb. So it's not going to be the exactly midpoint. Now the question is, calculation निकल रहा हूं, बस in general पूछ रहा हूं. Question is, near which charge you will get E equals to 0? Q1 or Q2?
Q1.
Q1, 4 microcoulomb. Why is it so?
क्योंकि 16 वाला चार्ज ज्यादा
Yes, 16 microcoulomb is a bigger magnitude, and due to which it will give a strong force in the nearby region of Q2. So if you want to decrease its effect, we have to select a point which is far from Q2. So let's say my point of interest is somewhere here, and this distance is R. So this remaining distance will be 3 minus R, because only this distance is R, total is 3 unit. So remaining part will be 3 minus R. Now, electric field due to charge Q1 will be in this direction, and electric field due to charge Q2 will be in this direction, right? And for E net to be 0, E1 should be equals to E2 apart from their direction. If you are including direction also, you should write it as E net is equals to vector E1 plus vector E2 equals to 0. And in vector form, if you want to write it, it will be E1 vector minus E2 vector. But we are not taking it in vector form, we are taking it in terms of magnitude. So magnitude of E1 vector should be equals to magnitude of E2 vector, because both of them are in opposite direction to each other. So E1 will be equals to E2. Now what is the value of E1? E1 will be K Q1 by R is equals to K Q2 by R. For Q2, R is 3 minus R. Yes. And square भी होता है शायद से K Q by R square ना. So this will be square also. Now if you will look at it, K will cancel out. So it will be Q1 by R square is equals to Q2 by 3 minus R square. And if you will arrange, Q1 by Q2 will be R by 3 minus R to the whole square, right? Okay, what is the value of Q1? It's 4 microcoulomb. What is the value of Q2? 16 microcoulomb. Microcoulomb, cancel. So R upon 3 minus R to the whole square. 4 4 ja. So R upon 3 minus R will be square root of 1 by 4. Am I right? So square root of 1 by 4 will be what? 1 by 2. And if you will cross multiply, it will be 2R equals to 3 minus R. So 3R will be 3 and r will be 1, which means the point of interest is at 1 meter distance from charge q1 and at 2 meter distance from charge q2. क्वेश्चन में इस तरीके का लैंग्वेज भी यूज किया जाता है, like E will be zero where E will be zero at 1 meter distance from charge q1, 2 meter distance from charge q2. Second option, E will be zero at 2 meter distance from charge q1, 1 meter distance from charge q2, or E will be zero at midpoint of the line joining charge q1 and q2. इस तरीके से. So you have to be careful कि कहां से distance का measurement हम कर रहे हैं. We can have different reference point. So I would answer it. E will be zero at 1 meter distance from charge q1 and at 2 meter distance from charge q2. Are you getting it? Or any doubt? आगे चलें. Next point in electric field is electric field lines. Electric field lines. कोई डिफाइन करेगा what are electric field lines? First point, electric field lines are the curve which are used to represent electric field in a region surrounding a charge. So electric field lines EFL, electric field lines are the curves used to represent electric field in a 3D region. Okay, electric field lines are the curves which are used to represent electric field E in a 3D region. Another definition for electric field line.
Strength of direction provided by
वो बोल दिया ना, रिप्रेजेंट करता है E को. और कुछ? The concept of electric field line was given by Michael Faraday. We also define electric field as electric field line is the curve. Electric field line is the curve on which electric field line is the curve on which tangent at a point on the curve, tangent at a point on the curve gives the direction of electric field E at that point. So this is somewhat precise definition for electric field lines. Electric field line EFL is any curve on which, if you will draw a tangent at any point of the curve, that tangent will give the direction of electric field E. For example, let's say I have a EFL like this, a curve, and there are different points. Let's say these are the points. So at these points, if you will draw a tangent, let's say this is the tangent. So this tangent will give the direction of electric field E on the curve. This will be the direction of electric field E on the curve. Electric field E and electric field E. Okay. We also know that electric field E will have the same direction as force on positive charge. So some authors state it as electric field line is a curve on which any positive charge will move in the direction of electric field, and which is true also, because if you are having a positive charge, then force on the positive charge will always be in the direction of electric field. So whatever will be the direction of electric field, in that direction we will have force, in that direction we will have acceleration, and in that direction we will have motion of the positive charge. So it can also be stated as electric field line is the curve on which a positive charge has to be positive. Electric field line is the curve on which a positive charge positive charge moves in the direction of electric field E. Any doubt? First point is electric field lines are used to represent electric field. Second point, this concept was given by Michael Faraday. Third point is the main definition of EFL. EFL is the curve on which tangent at any point on the curve gives the direction of electric field. And if you will release a positive charge, or if you will put a positive charge freely on the EFL, it will move in the direction of electric field. Okay, or any doubt? Now we can have different situations for the electric field strength. First of all, if we have a positive charge, what will be the direction of electric field lines? So from the positive charge, electric field lines emerge and they will move to infinity. So this is the condition for EFL of positive charge. Okay. So if you have a positive charge in a 3D space, you can imagine arrows are emerging from that positive charge, and it will create a 3D electric field like a football. Like you can imagine a charge at the center of the football, and arrows are coming out of the center of the football, and these arrows will be perpendicular to the surface of the football. Remember, electric field line is always radially outward from isolated positive charge. So in some book it is given as radially outward. Okay. If we have negative charge, for negative charge, obviously the electric field will be towards the negative charge. So electric field lines will start from infinity and they will terminate at negative charge. Okay. This is the infinity point. Understood or any doubt?
Yes, sir.
So remember, electric field lines will start from positive charge and terminate at infinity point. And for negative charge, electric field lines will start from the infinity point and will terminate at the negative charge. So for the negative charge, electric field is radially inward. radially inward. Okay. Next point is about the strength of electric field using electric field lines. So let's say we have a region, and in this region EFL are close to each other. If electric field lines are close to each other, it will represent a strong electric field. Strong electric field. Remember, degree of closeness of electric field lines is directly proportional to the magnitude of electric field. Closer the electric field lines, stronger will be the electric field. Okay. So if we have a region in which electric field lines are not very much close to each other, like this, they are far from each other, this represents that in this region we have weak electric field. Okay. Next, if you have a region in which electric field lines are exactly parallel to each other, like this, we call it uniform electric field. And if they are not parallel, in any region they are not parallel, they are going like this. This is known as non-uniform electric field. Okay. And if you will take the permutation and combination of these four situations, you will get uniform and strong electric field, non-uniform and strong electric field, weak and uniform electric field, weak and non-uniform electric field. So you can have strong uniform electric field, strong uniform electric field. Second, you can have weak uniform electric field. Third, you will have strong but non-uniform electric field. And the last one, weak and non-uniform. Weak and non-uniform electric field. So what will be the representation for these? If we are having a strong and uniform electric field, for strong EFL should be close to each other, and for uniform they must be parallel. You can have like this. Parallel to each other and close enough. This is the example for or representation for strong uniform electric field. Weak uniform electric field, for uniform it will be parallel. For weak, gap between the parallel electric field lines will be greater. Next, strong non-uniform. For strong, EFL will be close enough, and for non-uniform they are not going to be parallel. So let's say these are the EFL. This is strong and non-uniform. Weak and non-uniform. Weak and non-uniform will be something like this. This is weak and non-uniform. Okay, what is the physical sense or what is the meaning of uniform electric field and non-uniform electric field? Uniform electric field is an electric field whose value at any point of the space will be exactly same everywhere, and its direction will also be same at every point in the space. In case of non-uniform electric field, the value of electric field E in the space will be different at different points, different positions, and the direction will also be different for different points. For example, if I say, let's say in this classroom, the electric field is uniform. It means if you will look at any point in this classroom, the value of E will be same for all the points. If it is 2 unit at this point, it will be 2 unit at this point, it will be 2 unit at that point, everywhere it will be 2 unit. And its direction is also going to be same. If the direction of electric field is upward at any arbitrary point in the room, then at each and every point of the room, it will be in the upward direction with magnitude 2 unit everywhere. This is the meaning of uniform electric field. And non-uniform electric field means magnitude at different point will be different, direction may also be different. So if I have a 2 unit magnitude at a point in this room, and when I will change the point or the position of the point, in that case the magnitude is not going to be 2 unit, it may be 1 unit, 3 unit, or 4 unit. Same is for the direction. Direction will be continuously changing, it will be different for different point. So if at arbitrary point in the room the direction of electric field is upward, then at any other point in the room the direction of electric field may not be upward, it may be downward, it may be left or right also. So this is the sense, or this is the meaning of uniform electric field and non-uniform electric field. Strong and weak, I would say strong and weak is comparative to each other. If we are having two different regions with two different electric fields, then on the basis of comparison we can comment that one of the region is having a strong electric field and another one is having weak electric field. So if we have a region of a strong electric field, it means magnitude of electric field in this region at any point will be greater than the value of electric field in the another region where electric field is weak. So if I have an electric field of magnitude 5 Newton per Coulomb and I have an electric field of 15 Newton per Coulomb. So 15 Newton per Coulomb is an electric field which is stronger than 5 Newton per Coulomb. So this is the meaning of strong and weak. If I have only a isolated room with certain amount of electric field, I cannot comment whether it is strong or weak. अकेले बंदे को नहीं बोल सकते ना अपन स्ट्रॉन्ग और वीक. स्ट्रॉन्ग एंड वीक विल बी डिसाइडेड इन कंपैरिजन. लाइक इन दोनों की अगर हम कुश्ती करा दे तो जो जीत जाएगा दैट विल बी अ स्ट्रॉन्गर पर्सन. समझ में आ रही बात? कोई डाउट है? आई थिंक आज की सभा हमें यहीं समाप्त कर देनी चाहिए. टॉपिक भी कंप्लीट ही हो गया आप लोगों का. There are certain properties of the electric field lines. और 6 मिनट बचते हैं. I can cover it in that 6 minutes. नहीं टॉपिक पूरा हो जाएगा भाई. नहीं तो ये रह ही जाएगा फिर. भरोसा नहीं मैं कब आऊंगा फिर वापस. टुमारो तो टुमारो नहीं होता इधर. इधर का टुमारो कुछ और होता. Properties of EFL. First property is that electric field lines emerge radially outward from the positive charge. Second property, electric field lines are radially inward for the negative charge. Third point, if you will put a positive charge on the electric field line, it will move in the direction of electric field. Fourth property, if you will take a tangent at any point on the electric field line, this tangent will give the direction of electric field E. Okay. Next point, electric field line starting from positive charge will terminate at infinity point, and electric field lines starting from infinity will terminate at negative charge. Okay. Next important property which is very important, that is two electric field lines can never intersect each other. ये बहुत important property है, बहुत ज्यादा use भी होती है. So remember, two electric field lines never intersect each other. Why is it so? because if there is a hypothetical situation where two electric field lines intersect each other, then at the intersection point there will be two direction of electric field, and it is not practically possible. At a particular point in space, the direction of electric field will be exactly in one direction. It cannot be simultaneously in two directions. That's why two electric field lines never intersect each other. Okay, if you are having two charges with opposite polarity, positive and negative, close enough to each other, then electric field lines will emerge from the positive charge and will enter into the negative charge. Understood? And the most important point, electric field lines do not form closed loop, while magnetic field lines form closed loop. In other words, it implies that electric field line will start from positive charge and will end at the negative charge. It is not coming back from negative to positive charge. While in case of magnetic field lines will start from north pole, will go to the south pole, and then inside the magnet, they will come from south north again, so they will form closed loop. But electric field lines do not form closed loop. Next property is on the basis of इलेक्ट्रिक फील्ड लाइन यूनिफॉर्म एंड स्ट्रॉन्ग, वो ऑलरेडी मैं एक्सप्लेन कर चुका हूं क्या सेंस है उसका. नथिंग एल्स इज लेफ्ट, दैट्स इट.
इसका नाम क्या है जो ये रिप्रेजेंट कर रहा था कि इनसाइड द मैग्नेटिक फील्ड वो साउथ टू नॉर्थ जाती.
सोलेनोइड में देख सकते हैं. एनी डाउट? Okay. Last important property, which is again very important. If we have a metallic conductor, then the direction of electric field is always perpendicular to the surface of magnetic conductor. इसके ऊपर क्वेश्चन आता है, दोबारा बोल दे रहा हूँ. हाँ, दोबारा बोल दे रहा हूँ, इसके ऊपर क्वेश्चन आता है. डायरेक्शन ऑफ इलेक्ट्रिक फील्ड लाइन, और इलेक्ट्रिक फील्ड लाइन मेटेलिक कंडक्टर पर किस तरीके से काम करती है. So remember, inside metallic conductor there is no electric field, which means no EFL can enter inside the metallic conductor. First point. Second point, EFL is always perpendicular to the surface of metallic conductor. Perpendicular और normally भी बोलते हैं कई बार. So EFL is always normally or perpendicular to the metallic conductor's surface, and inside metallic conductor there will be electric field 0, which implies that no electric field lines can exist inside the metallic conductor. Understood? Electric field lines always flow from higher potential to lower potential. समझ में आ गई बात? That's it. आज का टॉपिक आपका समाप्त हुआ, कंप्लीट हुआ. ओके, अगला लेक्चर जब कभी होगा तो हम कुछ स्पेशल अरेंजमेंट की वजह से इलेक्ट्रिक फील्ड निकालना सीखेंगे, कैसे निकालते हैं. आज के लिए हमने केवल एक ही केस डिस्कस किया है, वो है पॉइंट चार्ज, एंड पॉइंट चार्ज की वजह से इलेक्ट्रिक फील्ड E का वैल्यू. अंडरस्टूड और एनी डाउट?
Understood, sir.
हाँ भाई, नालायक को